In this particular problem, we're asked to simplify the expression, and we have negative 16x to the third y z to the second over 24x y to the seventh z. So the first thing I'm going to do is I'm going to look at the numbers. I have negative 16 and 24, and I know that there's a common factor in both 16 and 24, and that common factor is 8. So I can reduce 16 and make it negative 2, and I can reduce 24 dividing by 8 and make it 3. So now my new numbers are going to be negative 2 over 3. Next I'm going to look at the variables. I have x to the third and I have x to the first. I have more x's on the top than I do on the bottom. How many more do I have on the top? 2 more. So I'm going to write down x squared. The other way of looking at that problem is you would take their exponents and subtract them, and it becomes 3 minus 1, which is 2. Next, I'm going to be looking at my y's. Where do I have more y's? Well, I have more y's on the bottom. How many more than I do on the top? 6. So I have y to the 6th. And then I have z's, and where do I have more z's? On the top. How many more? 1. So my final answer then is 2x to the second z divided by 3y to the 6th. In this problem, we're using scientific notation to calculate. So the first thing I'm going to do is look at the integers that I'm dealing with, not the powers of 10, but the integers. So I have 8 times 5, and I'm going to be dividing by 2. So just looking at the integers, not at the powers of 10. So I have 8 times 5, which is 40, divided by 2, which gives me 20. The next thing I'm going to do is I'm going to look at my powers of 10. So in the numerator, I have times 10 to the 4th, times 10 to the 10th. In the denominator, I have 10 to the 7th. So in the numerator, I can combine my powers of 10 by adding my exponents. So I end up with 20 times 10 to the 4 plus 10, all over 10 to the 7th. Simplifying the numerator, I end up with 20 times 10 to the 14th over 10 to the 7th. Where do I have more 10s? In the numerator. How many more? 7. So it becomes 20 times 10 to the 7th. And now you would think that you're done, but my 20 is not in scientific notation. I need to have a number between 1 and 10, and 20 is not a number between 1 and 10. So I'm going to just rewrite the 20 in scientific notation. So rewriting 20 in scientific notation, that becomes 2 times 10 to the first. And then I still have that times 10 to the 7th sitting there. Then I combine my exponents by adding them, and it becomes 2 times 10 to the 8th. So 20 times 10 to the 7th is the same as 2 times 10 to the 8th. And that's my answer. In this problem, we're taking x squared and multiplying it through a set of parentheses, 1 minus 5 over x plus 6 over x squared. So I'm going to use my distributive property. X squared times 1 gives me x squared. X squared times 5 over x. So it's going to be x squared times 5 over x. And then x squared times 6 over x squared. Now it might be helpful for you to write your x's when you're multiplying these with fractions, to write them as x squareds over 1. This first one I'm not multiplying times a fraction, so I don't need to worry about that. Then I'm going to look for like factors. Well, I have a common factor of x in each of these, so I can cancel out 1 here, and I'm going to cancel out 1 here. And then I have x squared here, and I can cancel that out with x squared here. So now simplifying, I end up with x squared minus 5x plus 6.